Hi there. In this particular video, things are going to get a little bit messy. So I'm making this a bonus video. At any time, if things look too scary, too messy, your head starts to hurt, you can skip ahead to the next video. What I'm going to be showing you in this video is a messier example of solving a quadratic equation by completing the square, when things don't work out quite so nicely. And then I'm going to show you where the quadratic formula comes from. In the next video, we're going to actually use the quadratic formula to solve some equations. You got to know how to do that. But you don't have to know where the formula comes from or why it looks the way it does to use it. So if you don't care about that, you don't really have to watch this. But if you're saying, why do I have to use that formula? Why is it set up like that? Why has it got all that stuff going on in it? And why is it like that instead of something else? Where'd it come from? Who dreamed up this formula anyway? That's what you'll see in this video. So here we go. I'm going to start by showing you another example of using the completing the square technique to solve a quadratic equation. The example we're going to look at here is 3x squared plus 4x minus 7 equals 0. And because there's a number in front of the x squared, and that makes things complicated when I'm trying to complete the square, I'm going to start by getting rid of that by dividing both sides of this equation by 3. So that made this nicer, but it made these kind of less nice because now they involve fractions. So now we have x squared plus 4 over 3x minus 7 over 3 equals 0. Now we continue on with our completing the square technique. I would leave the x squared and x terms where they are, but move the constant term to the other side of the equation. I'm going to add 7/3 to both sides. So x squared plus 4/3 x equals 7/3. Now what do I have to add here to complete the square, to make this a perfect square? Remember, the trick is, look at the number in front of the x, take half that number, and square it. So half of 4/3 would be 2/3. You could say it's 4/6, but that reduces to 2/3. And then if you square 2 over 3, you get 4 over 9. So I added 4 over 9 to both sides of this equation. So on the left, this is a perfect square. This is x plus 2/3 the quantity squared. And over here, to add these fractions, we would have to get a common denominator. So take the 7 over 3, multiply by 3 over 3, and we get 21 over 9. And then 21 over 9 plus 4 over 9 gives me 25 over 9. So over here, we got the number 25/9. Now we use that square root method. We have something squared equals a number, so the something equals plus or minus the square root of the number. And the square root of 25 over 9 is 5 over 3. So x plus 2/3 is either positive or negative 5/3. And then subtracting 2/3 on both sides, x equals negative 2/3 plus or minus 5/3. If you do the plus, you get negative 2/3 plus 5/3, which is 3/3, better known as 1. If you do the minus, you get negative 2/3 minus 5/3, which is negative 7/3. So those are the two solutions to this equation. Now, this particular equation could have been solved by factoring. That probably would have been easier, but we did it by the completing the square method just so we could see how that works. Now, suppose instead of these specific numbers, 3 and 4 and negative 7, we had other numbers. And instead of saying other specific numbers, what if we just use generic placeholders a and b and c? So we write it as ax squared plus bx plus c equals 0. And we go through this whole same procedure, these whole same set of steps, but with those letters in place of the specific numbers we were working with here. Let's see what happens then. So remember what we do first. We get it so that instead of something times x squared, it's just plain x squared. And I do that by dividing through on both sides by this number a. Then I get x squared plus b over ax plus c over a equals 0. Then I leave the x squared and x terms where they are, but get it so that the constant term is over on the other side of the equation. So I subtract c over a from both sides. Now x squared plus b over ax equals negative c over a. Now to complete the square, what I have to add on here is, look at the number in front of the x, that's b over a. Take half of that number, which would be b over 2a, and then square that. On top it's b squared, on the bottom the 2 and the a both get squared, so it's 4a squared. So I'm adding b squared over 4a squared to both sides of the equation. The left side is a perfect square. It's x plus b over 2a, the whole quantity squared. And on the right, I have these two fractions that are being added together. And if you want to add fractions, you need them to have the same denominator. So I'm going to take this and multiply by a 4 and another a, so that this becomes a 4a squared to match the second denominator. But I got to multiply the numerator by 4a at the same time. So that turns it into negative 4ac over negative 4a squared plus b squared over 4a squared. So now that they have the same denominator, I can put them together. I could have put it as negative 4ac plus b squared all over 4a squared, but instead let me put the b squared first. B squared minus 4ac all over 4a squared. Now we take square roots. If something squared equals something, then the something without the squaring equals plus or minus the square root of the something. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. This may be starting to look a little familiar to you. I seem to remember there's a b squared minus 4ac is under a square root as part of the quadratic formula. Let's see where we go from here. We've got the square root of this fractional expression. We can break that down into the square root of the numerator over the square root of the denominator. And we can say what the square root of the denominator is. The square root of 4a squared would just be 2a. Now remember, we want to solve for x. We want to get x by itself on one side. So to get rid of the plus b over 2a, we would subtract it, minus b over 2a on both sides. So x equals minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. And both of these fractions have the same denominator, so we can combine them all over that 2a. So then it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, friends and neighbors, is the famous quadratic formula. Now that we've gone through this whole business with these letters in place, and the letters can stand for any numbers you want, we know what the result is in terms of whatever those numbers are. So now we can jump straight to the solution by plugging those numbers for a, b, and c into this formula. So I'm going to stop this video here and come back in the next video. We'll rejoin anybody who got scared off by this video, and we'll talk about actually using this quadratic formula to solve some equations. We will see it in action.